So, hello everyone. I'm your host. I'm Gina from Arc and Codementor in Latin America. Thank you so much for taking the time to join us for our Tech Talk exploring the power of Swift beyond app development. That is part of our remote engineering job fair series in Latin America and organized by ARC. We connect great developers with companies around the world. And if you'd love to learn more about us, we're going to share the link in the chat. Today, we will take you through a few examples of how Swift can shine in a lot of different situations, from simple command line scripts and tools to server side applications. And just to make sure you take full advantage of your talk, um, since we have some interference, okay, just as a reminder, please mute yourselves so we don't have any awkward noises during the talk. So yeah, please just make sure that you're muted right now. Okay, so let's get back to our introduction. Feel free to drop your questions for our speaker today in the Q&A section. You will also find the icon in the bar below. We will answer them by the end of the talk. And don't worry about making notes right now because we will send a recording through email right after the chat. So, yeah, let's welcome our special guest today. Here with us is Paul. He is a senior iOS developer working in the iPlayer team at the BBC. He has more than 5 years of experience building and architecting iOS apps that are used by millions of users. And he also writes about all things Swift in his blog. And of course, he speaks at tech conferences. So, without further ado, Paul, take it away.
Hello, how you doing? How's everyone doing? Glad to see so many people from all over the world. Just wanted to say I'm joining from the UK. Yeah, do you want me to start my talk, Gina?
Yes, please.
Yeah,
Whenever you're
cool,
ready, you can share a screen.
awesome. Give me 2 seconds. Let me just get that right. Let me share screen. Cool. Right. I'm guessing you can all see that, right? You can see my screen. Awesome. So yeah, hello everyone. I'm Paul, and welcome to my talk on exploring the power of Swift way beyond app development. Before we get started with the talk, first of all, I'm Paul. I'm a senior iOS engineer, as Gina said, at the BBC iPlayer team. I am from Barcelona in Spain, but I am based in Manchester. I have lived in the UK for a long time, so 8, 9 years now. And my girlfriend is from Scotland, so if you can hear like a weird mix of accents, that's where all of that is coming from. I love Swift and developer tooling. I'm an iOS developer, and I like the building compiler side of things, as you'll see throughout this talk. And this is what kind of like inspired the topic of this talk. And as a random fact, I love football and I collect football shirts. I've been doing it since I was a kid. So my parents would travel a lot and they would bring me a T-shirt of a football team of the place that they travel to. So I kept it up, and I've got a lot of T-shirts, more than I'm happy to admit. Cool. So just diving into the talk, just a bit of context about what I'm gonna be speaking about today. For a long time, I've been doing as much as possible with Swift. So whenever I try to start a project, a command line tool, anything I do in my personal time, I always try to do it with Swift first. And if that fails, I try to look for an alternative, but I make an effort to, try and use Swift first. So I'm going to talk about how, because when we think of Swift, we think of an Apple language, and it really is, even though it's open source now. And we think of like macOS, iOS applications, but it can go way beyond that. And an example of that is on the right-hand side. It's an article from my blog about scripting in Swift. So I wrote a little like script, which acted as a Git hook for something that I had to do at work. And I just chose to do it with Swift because it was possible. And yeah, because I'm very comfortable with it. I'm going to show a lot of interesting Swift tools, and I'm hopefully encourage you and inspire you to use Swift a lot more in your day-to-day. And maybe if you're very new to Swift and you're going to think like, oh, I don't want to learn that because it's an Apple, language, and I don't want to do an iOS application or a macOS application. Well, it can be used for a lot more than that. So hopefully I can encourage you to use Swift more. I'm going to take a little script that I wrote a while back, and I'm going to show you how you can turn it into a full stack application by reusing the same core logic, the same Swift code in many, many different environments. We're going to work on a Swift package monorepo. I know it's very, very trendy and it's a hot topic at the moment, the topic of monorepos in JavaScript and in web development. So I'm just going to show you that there's ways of doing that kind of thing in Swift as well. And you can have a Swift package where you can build like multiple targets for very different environments. So we're going to go through that as well today. And just to say, there's going to be code examples for everyone. I do like to build in public as much as I can, and I do like to open source everything I do. So what I'm going to cover in this talk, it's all on GitHub. It's all public, so you can go copy any code you want, look at anything you want. It's all, for everyone to take a look at. So you might be wondering, why Swift though? What makes Swift like a good language choice? Well, first of all, it's got type safety, and it's a compiled language. So you basically get a lot of safety at compile time, and you get warned about errors at compile time. It leads to less runtime crashes, basically. It also has a low memory footprint. It doesn't consume as much memory as other alternatives. You can see in this graph, in this table from a study that was released not that long ago, and it compares algorithms, it benchmarks them across different languages. And for example, here you can see that Swift ranks quite high in this specific algorithm. It also has a great development experience. It's got a degree of familiarity. I don't know how many people here are iOS developers, but for us, we use Swift on our day-to-days. It's what we know best. And that degree of familiarity makes it very easy to get started. Like, how to do things as like a network request, grab a file from the system. So doing it in Swift is a lot, easier than with other languages for us. It's got a mature and amazing community. And a lot of the tools that I'm going to show today are driven by this community. And Swift is open source now, so you can, contribute to Swift code as much as you want. You can grab, I'm going to show how people have forked the Swift language and made it like extensible and build like extension for WebAssembly, for example. And because this is kind of my development with other languages, it's literally, if there was a book about me writing, for example, scripts with Bash, it would basically be this, copying and pasting from Stack Overflow. I quite like Swift because I've got, that knowledge that I don't have to learn a new language to do something that I want to achieve. So what we're going to be looking at is a tool that I made a while back called Reading Time. So Reading Time is a tool to get an estimated reading time for a Markdown file. So if you're not familiar with Markdown, it's basically a file format. As you can see on the right, it's very, very common with blogging websites, readmes on GitHub. And you can see you can have like images, links, you can even have emojis, text, titles. So this tool, what it does, it's inspired by Medium's reading time feature and other blogging sites, and it takes the number of words in a given file and it divides it by a constant, which is words per minute, and it extracts an estimated reading time from that. This tool is written entirely in Swift. It's distributed as a Swift package, as you'll see today, with products such as a library for iOS and macOS applications, executables for Windows, Linux, and Apple platforms. It's got a HTTP API and playgrounds. And the best thing about this is that it's only written in Swift. There's no other languages involved, except for one minor use case that I'll describe a bit later on. And I'll take you through how to get it running everywhere with just Swift on its own. So where it all began. So the initial idea was I wanted to create a script that ran through all my blog posts in my website. And it read all the Markdown content in them, and it got estimated reading times for all of them, so I could update the metadata in those Markdown files. So instead of creating a Bash script or a JavaScript file to do it, I decided to go with Swift because I'm most comfortable with it. So I created a plain text file and I added a shebang to it, as you would do with like Unix executables. So what this does is it tells, when you run this file as an executable, it will use the Swift interpreter, and it will pass all the contents of the file to Swift. So we'll tell it, to run this file, you need to execute Swift. So I can import Foundation, which imports all the standard library from Swift. Then I can read the command line arguments from it. This is very like as you would do in Swift. In this case, you see I only want to pass one command line argument, but there's always going to be one present anyway. So the first one is going to be taken by the contents of this file, and the second one is going to be passed by the user. So the user is going to say, I'm going to pass a path to a Markdown file. And then once I've got that, I can retrieve the path to the Markdown file. I can get the contents. So this is just standard Swift code for reading contents from a file. So you get a string. You remove the emojis because you kind of don't want to count the emojis from that string as words. Then you get the time interval in seconds, and you print the formatted version of the time. So it took to kind of read that file. So this is going to be an estimated average time that it takes to read a given Markdown file. So we can just run it, right? It's just a normal text file. So what we have to do, as you would do with Bash or Python or JavaScript, you just make it executable, and then you just run it, pass it a Markdown file, and you are told that it takes 1 minute and 30 seconds to run. So that's it. We've got I had what I needed at this point. But the problem was that this wasn't really scalable. So the problem with this is if I wanted to take this logic and make it into an application that I wanted to run in my my iOS app, or I wanted to make a little playground on a macOS app, then I couldn't really reuse this logic because it wasn't a library. I couldn't import the script. It's also worth mentioning that using this, as opposed to using tools like Node, you can't really import third-party libraries. So only the foundation, the standard library for Swift, can be used with Swift scripts. And what this meant is that I wanted to do some Markdown modifications because, as you can see on the right, there's images and there's titles, and the URLs were being counted, but they're not really shown to the user. So I wanted to improve this, and I wanted to use a library distributed by Apple, but I just couldn't because I could only use the Foundation APIs. So another big downside of this approach is that the system, as I said, you define a shebang, so you tell the Swift interpreter that it needs to run that code. But the problem is that the system needs to have Swift installed to run the script. So basically, if I wanted to share this with any of my colleagues that wanted to, do a similar task, they would need to install like Swift in their system. Or if I wanted to distribute this as an executable that people could go and download and use, I couldn't really do this because, you need Swift installed to run the script, which is not ideal. So as I said, I need a better way to distribute it. So what I did was to create a Swift package. So to create a Swift package, you basically just run Swift package init, and in this case, I'm gonna make it of type library. You can make different types of this. And this is very similar to doing an npm init. So it will create a package where you can, have a definition of all the targets you're gonna have, all the scripts you're gonna run, and all the dependencies your package is gonna have. So once you do this, you're gonna end up with something like this, which is a package.swift file. It's got two targets. Basically, the target is a library, and it's got a product that is also a library called reading time. So as I said earlier, I wanted to import some dependencies. So now I can do that. So I can bring in the Swift Markdown dependency. I can make it a dependency on reading time on the target. And that's it. That's all I need to do to set up my project. So now I can, move that logic that I had in the script into a library. And what this will allow me is to basically, if I want to make an iOS app that reuses the same logic, I can just put it in this code and just import it from wherever I want to use it. So the API for this library is very simple. It's just a single enum so that it cannot be initialized with a static function called calculate. And what this calculate function will take in as arguments is a content, which is a string, a Markdown string, and words per minute, which is a constant, which will default to 200, which is, I believe, what Medium uses, but it can be overridden by the client to whatever it needs to be. So to do this, we go back to what we had in the script, but we make it a bit better. So we want to rewrite the Markdown. So what this will do is it will wrap that Swift Markdown library that I brought in as a dependency, and it will just remove the link URL, so only the link title, which is what's shown to the user, stays, and it will remove any images because I didn't want to count them towards the final word count and the reading time. Then again, as you saw in the script, I can just take the content without emojis. I just want to remove the emojis from the markdown. Then I get the time interval in minutes, then I convert it to seconds. So literally just the word count of that string divided by a constant, words per minute, that gives me minutes. And then I can calculate the time interval in seconds and just return a rounded version of it. This is literally what it's going to do. It's not going to format any strings. It's not going to do anything. It just returns that. So now we've got a library that we can use. But the problem is that we've lost the ability of running that script, right? So what we initially had, which was that, the whole idea of running a script that would parse all the markdown files and give me estimated reading times, doesn't really work anymore. So we need to get that back. And fortunately for us, it's very, very simple. And not only we're going to get that functionality back, but we're also going to make it an executable target that's going to run on Ubuntu, Windows, and macOS. So it's going to be a true cross-platform command line tool. And it's not going to require the systems to have Swift installed in them. We can distribute it as a normal executable that people can just grab, run, and not have any more problems. And as I said, it's a monorepo, right? So we go back to our package.swift. Very, very similar to, if you're not familiar with Swift, very similar to a package.json, basically. And what we do is define a new target. So in this case, it's going to be an executable called reading time CLI. And the dependency is only going to be one for now, which is going to be reading time, which is that library we've just created. Then we want to bring in a package to make our life easier. This is a package provided by Apple called Swift Argument Parser, which makes it very easy to create executables in Swift. Again, we add it as a dependency. And one important thing is that we have to make a product. So this, by defining an executable product, what this is going to do is when we build reading time CLI, it's going to create an executable and it's going to put it on our build folder. So we can, if we had a GitHub action that run and build this executable, we could just upload it as an artifact or make a release and just distribute it to our users. So we need to write some code for this target, right? So it doesn't really magically write itself. So we need to import our library and do something with it. So the first thing we do is we decorate a struct with main. So we tell Swift is the entry point. We make it a parsable command. Again, this is a library provided by Apple, which makes it easier to create command line tools. And with this library, you can define arguments. So you can define a path to a markdown file, the same thing that our script did. So we're just trying to get the functionality back. And we can just call a run function, which is implement a run function, which will be the code that gets executed when the executable runs. We get the contents for a given file from that path passed in by the user. We import reading time, and now we just do reading time.calculate. This is the library that we created earlier. So our executable now uses that library, and then we can just format the time in a nice string, and then we can just print it to the user. And if that formatting fails, because it could potentially fail, we can just print the number of seconds. So we've got a nice way to, we've made our script better. We've got all the functionality back. And now we're going to be able to get it to run on macOS, Ubuntu, and Windows just as a plain executable, not having the requirement of the system having to install Swift. So how do we actually get this executable? So for macOS, it's very, very simple. We just run Swift build with a configuration of release. And we have to define the product in this case. So the product is, we basically have to define this because we're using our package.swift as a monorepo. And if we didn't define this, it would just build absolutely everything. And we only want to build reading time CLI. So once we do this, it will just build for production. And then it will generate a file that we can check with the file command from the terminal. And we can see that it's a 64-bit executable ARM64. Now, this is only working for Silicon. You can, for Apple Silicon, for the M1 Max. but you can actually pass an extra architecture x86-64 to that Swift build command, and it will just build it for Intel Macs as well in the same executable. So it's super, super easy. So we can move on to compiling for Ubuntu, right? We want a different executable that can run on Ubuntu, but it's not as easy as the macOS compilation. There are a few options to do this. So we could do a Docker build, we could run it on an Ubuntu machine, we could use a GitHub action to do so. But I wanted to show how to cross-compile for Ubuntu using Swift build. So the easiest way to explain cross-compilation is that you're basically running, you're building for Linux, you're building for Ubuntu, but you're actually building on macOS. So when you cross-compile, there's two concepts. One of them is a host, which is going to be macOS. It's the computer that's building the program. And then you've got a target, which is the one that's running the program or that's meant to run the program, which is Linux, Ubuntu in this case. But to do this, you need a destination.json, which looks a bit like this. And you need to pass this to the Swift build system. And this looks like, this has information such as the SDK to use. So you know the SDK for Ubuntu, the Swift toolchain to use, the target triple, the architecture triple that you wanna target. So in this case, it's gonna be Linux unknown x86-64, and this implies that you need the target SDK and toolchain downloaded on your system, and this can be very, very daunting. So if you can come out with something in this talk, there is an awesome community out there, and you don't have to do it yourself. So what I would suggest is to use this tool by Kid Smiley, and it's called SwiftPM Linux Cross. And what it does is, with a simple command that can be installed using Homebrew, it installs all the required SDKs. It creates a destination.json, but it not only stops at that, but it also gives you a Swift build command that you can copy and paste into your terminal, and you can build your Swift package, and it will provide an executable out for Ubuntu without you having to do much work, really. And one thing to bear in mind is that the version of Swift that you use for the toolchains you download with this tool needs to match the build version of Swift that you use in your project. Otherwise, you're going to run into a million issues. So how do we run this? What do we have to run? So we can run setup Swift PM toolchain after we install it using Homebrew, sorry. We pass it an Ubuntu release. So let's say we want to build for Focal. We pass it an architecture, which is ARM64, and we pass it a Swift version. And that's literally all you have to do to set up all the environment you need to build for Ubuntu. And once you do this, you'll get a bunch of files created for you, which will look a bit like this. You'll get the packages and the toolchain that you need. So this will contain all the SDKs, packages, Swift toolchain that you need to build for Ubuntu. And then you'll get a destination and destination static, which you can pass to the Swift build system. Without going into too much detail about the difference between these two JSON files, one of them links the Swift standard library that statically into the executable, which I think is preferred if you want to distribute an executable. So yeah, then you can run Swift build or Swift build with a static Swift stdlib, and this is all you literally have to do to build for Ubuntu. But once you run these commands on your project, you're probably going to run into some issues, because some APIs are actually not available in all toolchains. And because the Swift open source and the Swift toolchain for Ubuntu is actually a limited version of what you get for macOS and iOS, you're likely to run into some issues. But I would say don't give up, because there are ways around it. And the ways around it are compiler directives. And this can really, really help with this. So this happened in my reading time project. So the problem I had was I had this count function, which basically extracted the number of words in a given string. And I was passing it an option called bywords, but it turns out that this bywords option is only available in Apple platforms. Anything outside the Apple platforms will fail. So my cross compilation to Windows or to Linux were actually failing. So what I had to do was basically to make sure that if the operating system is not Linux, then I could run this. But if it was Linux or anything, actually anything outside the Apple ecosystem, I wanted to run a different implementation. So this one uses character sets. It's a bit of a different approach. It's actually a bit less scalable. It doesn't work for all languages, but it kind of got me past the issues. And yeah, as I said, the Windows build actually faces the exact same issues. And if you want to learn a bit more about it, I have an article on the topic. So I'll leave a link. I'll share the slides afterwards. I'm sure I can get it to everyone. But yeah, if you want to take a look, I left the link there. And yeah, so you get past these issues. You've got an executable for Ubuntu, and then there's one last hurdle that we need to get past, which is Windows. And Windows was a fun one because Docker and cross-compilation didn't really work for me, but luckily there was a GitHub action by Salim Abdul Rasul, who is basically the driving force of Swift on Windows. And I just basically made a GitHub action which run in a Windows machine. It set up the whole Swift Windows toolchain using this GitHub action. And all I had to do was to run Swift build on it. And I literally got an executable out that I could upload as an artifact. Again, the project is completely open source, so you can go look at the GitHub action or any code that I've mentioned in the slides and have a look. And yeah, again, don't do it yourself. There's an awesome community behind Swift, and there's probably someone who's already been through the pain and has documented what they've done, and in this case has provided a solution to make our lives easier. So might as well use it. And yeah, this is a frustrated tweet from me saying, let's get the Swift command line tool running on Windows 2. And as you can see on the picture, it failed a lot. I had to make a lot of changes, but it eventually got there, and I managed to get like the 3 platforms working, and I managed to distribute my executable. And again, only using Swift. I didn't really have to change scopes, like switch context. I just was able to use Swift for absolutely everything. And a bit of like timely news that actually got announced a couple of weeks ago. So Arc, I don't know if anyone's heard about the browser company or the Arc browser, but it's a macOS only app written in Swift, and it's going to be available on Windows next year. But you're probably wondering now, why the hell is he telling me this? The good thing is that they've decided to share, and the interesting thing for me is they decided to share the same code base and use Swift for the Windows build, which is groundbreaking, really. They've decided to like work on the ecosystem because they've got many challenges ahead. There's no Xcode, there's no instruments, there's no async await. There's not really an easy way of getting UI working on Swift UI. On Windows. But they've decided to kind of, instead of going for like an easy approach, they've decided to like keep the same code base, and because they're betting on Swift, they've kind of like decided to make it available cross-platform and take the bullet and work on the ecosystem. And yeah, it could be great for the community. It could be great for the Swift language, and they will potentially open source all the work that they've done. So it's a very, very interesting opportunity, and it really shows how far Swift is going and how big it's becoming, and how much potential it's got for being a language that's used way beyond macOS and iOS development. And that's it. We've got 3 executables that have been built only using Swift for 3 different platforms, and we don't have to install Swift in any system or anything. So let's move on. Let's maybe take it to the server and create an API, right? We can do that with Swift. So we're going to do that in an AWS Lambda. So we go back to our Package.swift and we create a new target. In this case, it's going to be an executable called reading time lambda. And I'm going to bring in a package called Swift AWS Lambda Runtime. And this comes from the Swift server GitHub account. And yeah, I bring in 2 dependencies. One of them is going to be the AWS Lambda Runtime. So this will allow me to create Lambda handlers and closures that I can run my code in. So every time the Lambda gets triggered, I can run some Swift code. And then some AWS Lambda events, which will let me pass, react to data and triggers that wake up the Lambda. So my plan is to put a HTTP API gateway in front of my Lambda. So every time a root gets called, every time a REST request gets made, the Lambda runs, and it runs Swift code. And yeah, finally, we imported reading time as well, because that's the core of our logic. That's what we want to run. And we're ready to write some code. So how do we write a Lambda in Swift? So this is going to be very similar. If you're familiar with Node.js or Edge functions, you're going to be familiar with like a closure, a handler, a function that you define in a file, and it gets passed in a context, a request, which comes from API gateway in this case, and a callback. So basically, it's an asynchronous operation, and you call a callback with a response, whether a success or a failure. And yeah, when you're done performing tasks, you can just call this and inform the client that you're sending them back a response. So the first thing I do is I make sure that the method is a post request, because I want to get a body, I want to get some content, a markdown string that I can calculate. And then I make sure that the path is actually the right one, just to make sure that there's no calls that I'm not expecting in this handler. And then if it's not, then I can just return with a status code of not found, which is going to be a 404. Then I just decode into a codable type. So this is going to decode the contents of my request into a Swift type. This is just going to have one field, which is going to be content. It's just going to be a JSON request, and it's going to have a markdown string. I add some error handling. Again, if something goes wrong decoding this request, then I'm going to presume that the request was malformed. So I'm going to just return 400 or a bad request. Then again, this is going to look familiar. We just call reading time to calculate. So we use our library to calculate an average estimated reading time for the content of the request. And then we can just return with a status code of OK, as you can see, and an API gateway response with a body, and the body is going to be just the reading time. It's just going to be a JSON object with a single key value pair of time and then the seconds. So how do we deploy this? It's not as easy as if you were deploying JavaScript, for example. You need to go through a couple more steps. So this is the function overview. So I've got a reading time lambda. This is the Swift code that's going to get executed. And then I've got an API gateway. This is what, every time you call a root on this API gateway, it's going to wake up the lambda and it's going to run some Swift code. It's very, very easy AWS setup, but if you've got any questions, I'm happy to answer them. And yeah, to get this running, we need to build an executable essentially, and we do this using Docker, and we run on the Swift 5.6 Amazon Linux architecture, and this image is provided by Apple themselves, and I'm pretty sure you can find this exact command in the AWS repo as well. And then there's other ways you can do it. You can put it in an S3 bucket, or you can update the source from your CI. But for the purpose of this presentation, I'm using a script from the Swift server repo as well, which you can call on your package after you've run docker run, and you call package.sh. And what this will do is it will package all the needed, all the executable, the bootstrap code, and everything the Lambda needs into a zip file that then you can upload into the AWS Lambda, and you're ready to run some code. And you're ready to basically use it. So what does this look like? So I've got a little slide here. And as you can see, we've got an endpoint, which is going to be from Amazon AWS, and it's going to call the calculate endpoint on the HTTP API. It's going to pass in some content. I believe this is one of my articles, like the content of one of my articles. And once it executes the request, it returns a 200 in this case, and it returns the time it took in seconds. So it took 319 seconds to as an average reading time. So yeah, we've got it in the server. So I didn't want to really stop there, and I wanted to make like something that didn't require an internet connection, but it was very, very easy to set up and play with. So I decided to make a little online playground. And I went ahead and did it with Swift as well. So I used two libraries, one called Vapor, which allows you to create little like servers, and one called Plot, which lets you write HTML using Swift. So again, we create a new target, we import two dependencies. One is Vapor, which allows you, as I said, to create services and servers. And the other one is Plot, which you can create HTML with Swift. We create a reading time site as a target. So this will contain all the logic and code for our server. We import Vapor and Plot and our library reading time. And then we just create an executable target, which is going to be a reading time site runner. So all this is going to do is spin up a server, and we can see our website, basically. So I'm going to go very, very quickly over this because there's a lot of like setup that you need to do with Vapor, but the whole of the application logic is going to be in like the whole of the server logic, and the roots are going to be defined in a roots method. And in this case, I'm going to define a get. So I'm going to let it handle get requests on the index endpoint, so at the root of the domain, and it's going to return some HTML. But this HTML is actually going to be written in Swift and then converted into a string. So as you can see, it looks like standard HTML, but it's using Swift types. So it's got a head where I set a title, I import some styles, then I define a body. I make a wrapper class, wrapper div with a class of app. I add a h1. I add a form, and this form is going to have a method of post. So every time the form is submitted, it's going to make a post request to this same endpoint. It's going to have a text area because I want the users to write some Markdown code. It's going to have somewhere where we can display this estimated reading time from the Markdown code that they've provided. And then finally, it's going to have a button of type submit. So every time this button is pressed, the form will submit, and it will send a post request with the content of the text area to the root of the domain. So let's have a look at what this looks like. So here's a small video that I recorded. So you can see that I enter some Markdown code, then I hit submit, and then I get an error. And the reason is not found. And as I said, the form will submit a post request, but we're not really handling that. But it's very, very easy to do that with Vapor. So we can just add the missing root, and it's going to be a post request again on the index of on the root of the domain. And what we're going to do is, again, we're going to decode the contents of the request. In this case, it's just going to be one variable from the text area. It's going to be the content of the text area. We are going to calculate the reading time with our library. And again, this is running server side. So we can run our Swift code that we originally had server side. And then we create a query parameter that we can then return to the get endpoint. We can make a redirect to the root of the application with a query parameter that we can then use to display the reading time. So we need to handle this query parameter because we didn't do that before. We just returned HTML. So how do we do this? It's very, very easy. We just do, we query the request. So we just say request.query.get, and we know it's strongly typed. So we know it's going to be a string, and it's going to be at the path reading time. So at the query parameter called reading time. And then with this, it's very nice because we can do a .if with this library with plot. And if reading time is not nil, then we can show conditionally render the estimated reading time. So only render that H3 if there is a reading time to display. So going back to the video I showed you before, we can see that now when I paste in some code and I calculate the reading time, you can see that it prints some estimated reading time. So that's it. We fixed the issue, and we've got a website that's built completely using Swift. So I wanted to, for the last bit of the presentation, I wanted to take it one step further and show you that how far Swift can go. So we can actually call Swift from JavaScript. So let's consider the following HTML file. So this file looks very, very similar to what we had in Swift before. It's got a text area and it's got a button. And how are we, we want, when the user types in something into the text area and they hit submit, we want to actually, calculate how long it would take to read that Markdown content that they've entered. So how do we do this? We can do it with WebAssembly. So if you're not familiar with WebAssembly, it is a binary format which is compatible with web technologies. It can be compiled from languages such as Swift, Go, Rust, and many others. It does produce a wasm file. That's the format that it produces. Wasm files can be imported from JavaScript, and the WebAssembly JavaScript API, which is used to import these wasm files, is widely supported across all modern browsers. As you can see here, most modern browsers actually support it and have supported it for a while, and it's got about, at the time I made this presentation, it had about 96.18% of all global users could actually use the WebAssembly API. So it's quite safe to use. But how do we compile Swift code to WebAssembly? What goes into that? Well, we can use an open source project called Swift wasm, and it provides a set of tools to compile Swift to WebAssembly. It's got a forked Swift toolchain that adds WebAssembly compatibility, and you can make any executable targets you can use any executable targets in Swift packages to produce wasm binaries. And then through a bunch of like different selectors and property wrappers, you can actually, not property wrappers, sorry, through selectors, you can actually expose functions to JavaScript. There is an amazing book on the topic available for free on their website. It's book.swiftwasm.org, and I would recommend, if you're interested in the topic, to give it a look. So in this case, I'm going to use a library, a Swift library from SwiftWasm as well, called JavaScript Kit. So it allows you to interact with JavaScript through WebAssembly and Swift. And I will make use of a bundler called Carton, which basically generates the wasm binary, and it generates a bit of needed glue code. So as I said, you need the WebAssembly API to import the wasm file, so it will generate that for you. And what this will allow me to do is to read the values from the vanilla JavaScript side, from the HTML side you saw before, and just do some processing and print to the console in this case. So back to our package.swift, we create an executable. Again, this is a monorepo, so we just create an executable target called reading time wasm. We bring in a dependency called JavaScript Kit, and we state that JavaScript Kit is a dependency on reading time wasm. We import our original library, the one we wrote at the beginning, and then we define it as a product, as an executable product, so we can get, so that Carton can generate a bundle from it and a wasm file. So writing some code, a word of warning now, this is going to look a lot like JavaScript, but you'll have to trust me. Well, you can see the code on the repo. This is Swift. So as you would do with JavaScript, you can just do, you can get the document. From this document, you can do a query selector, so you can get the reading time button, sorry, and you can pass it an onClick. And in this onClick, you can do another query selector with the document to get the text area. You can then get the text from that HTML element, then call readingtime.calculate on it, and just print its values. And because we're not going to do anything else, we don't want any other side effects, we just return null. And what this is going to do is just, every time the button gets pressed, it's going to grab the values from the text area, and it's going to output the estimated reading time. Then we just use Carton bundle function to generate all the glue code, and this is going to make a wasm file. It's going to make the necessary JavaScript code to import this wasm file, and it's going to generate a bunch of other resources so that we can interact with JavaScript from Swift. And then here is an example of it running. So when we hit calculate, it's gonna, it gets the values from the text area, and it prints that it took 2 seconds to read. And that's pretty much it for what we're gonna build today. So I'm just gonna recap very quickly of what we've built using Swift. So we've gone from a very simple script for macOS to a library for all Apple platforms. And this library was the initial step to get us to reuse that logic throughout the whole monorepo. A command line tool that was, for macOS, Windows, and Linux. An API using AWS Lambdas. An online playground using Vapor and Plot. And finally, a wasm binary, which can run on the web and anywhere that supports WebAssembly, really. And I wanted to do a quick shout out before I go, because I really think this showcases a lot of the amazing work and how how much length you can go with Swift. There's a library called Deck UI, and what this library does is it allows you to create slide decks. So it creates presentations with Swift. So you can basically interact with Swift UI components, and you can run code live on your slides, which I think is very, very cool. It's done by an amazing member of the community called Josh Holtz. So I just wanted to share it in case anyone's interested. And yeah, that's about it for my presentation. Don't forget to say hi. I'm very active on Twitter. I hope it sticks around because I really like it. I blog quite a lot on polpiella.dev, and then I started an iOS CI newsletter recently. I think it was about a month or so ago. So if anyone wants to sign up for that, there's a link to it if you're an iOS developer and want to learn and stay up to date with CI news. There's a newsletter for you. And yeah, thank you very much, everyone, for listening. It's been a pleasure.
Thank you so much for Paul for this insightful talk. Um, yeah, so if anyone at this point has any questions, please drop them in the Q&A box right now. We don't have any questions so far, so I hope everything is clear for everyone. Still, we will share the recording of this talk after, and feel free to get in touch with Paul in all his channels that we will be posting right now. Since we don't have any questions right now, I would like to move on to a rapid fire Q&A session with Paul, more like interview style. So I'm going to ask you just very short questions, and please just tell me whatever comes to mind.
Awesome. Sounds interesting.
Great. Okay, so let's get started. Paul, what's one advice that you wish you'd have 1 year ago?
Uh, Maybe not 1 year ago, but I would say at the beginning of my career, focus on the fundamentals and don't rush. I would say that's yeah, definitely don't rush, don't try. Take your time. I follow a streamer that always says it's a marathon, it's not a sprint. So yeah, do that because I've been beaten by that a few times.
So, like, small progress is better than just like big leaps and then go
Yeah,
backwards. And it
yeah,
applies on programming as well.
absolutely. Yeah, absolutely.
Perfect. Okay, next question. So, if you have like a crystal ball, if you can see the future, what would be your prediction for what's happening with the mobile industry in the next year?
I think I have to be very biased here, but I think even more shift towards native development, and I would like to see hopefully a bit more growth in like native-ish multi-platform approaches. So, for example, what I mentioned in the talk about Arc. Reusing Swift for the Windows build, I would like to see that part of the Swift ecosystem grow. And if I had to say, I think that it's just the community and Swift is going to get bigger and bigger. And the same goes for like Kotlin and Android. I think native development has proven time and time again that it's the best approach for mobile development.
Perfect. Let's see if that happens next year, just around the corner. Okay, so our last quick question is, what's the most recent moment when you're programming that makes you think, wow, I love my job and I love programming so much?
Mm, I'd have to think about that. I think I th- I would have to say just like releasing or fixing. I have to say like fixing a bug, for example, or being like stuck on something for a while and then feeling. I feel like it goes for me in two polar opposites that are very related at the same time. So sometimes I feel like I'm very, very stuck, and it happens to everyone. And you get stuck on a feature, and you're like, oh, imposter syndrome starts kicking in, and you're like, oh, I can't do my job. I'm a fraud. And then you step away from your desk, you come back, you fix it, and it's one of like the best feelings, I would say. So I think being stuck on something and then fixing it, and that sense of like accomplishment is why I love doing what I do, and just finding solutions to problems. I think that's what we as engineers need to do, and it's why I love what I do. It's just very very complex problems, finding simple solutions for them, or just approaching something that I'm scared about is something I like as well, and approaching something that it's a bit terrifying. It's a big piece of work, and you're there, and your task is to fix it. I think that's why, yeah, I love what I do.
That's great. We can feel that you're passionate about what you do. So if we have no passion, then probably we shouldn't be doing it.
Definitely.
Well, Paul, can you share with us what's next for you? Like maybe if you have any exciting plans for your career next, or yeah, something that like for attendees to get to know what are you going to be working on in the future?
hmm So yeah, I think my main focus at the moment is on. So I work for the BBC. I really enjoy what I do, but a lot of my focus at the moment on my free time is on speaking, on like public speaking and going to conferences. I think it's something I've been doing a fair amount this year. So yeah, trying to work on talks and submitting proposals. And I want to say something as well. It's never too soon, like to speak. And I heard something at a conference last week of someone I really admire and I really look up to. It's like he said that no one's born a good speaker. Like you just learn by practice. And the first conference is always, can always be a mess, or it can always be like, you're scared to do it. But no one's born a good speaker. You just learn by practice. So I want to encourage anyone who wants to do it and feels like they can't, you definitely can. And yeah, other than that, just working on. I feel like I've not been working on doing articles as much recently, so I want to get back into that. And yeah, my newsletter as well. It's a big focus. It's quite new still, and I started with I don't know if anyone's familiar with Review, which is the Twitter service for newsletter, but with everything going on at the moment, they've decided to kind of kill it by the end of the year. So I had to migrate everything to a new service after only 2 issues of my newsletter, which is very annoying. But yeah, I'll be working on that, basically sharing content and trying to grow in the community. It's kind of my goal for next year as well. I really enjoy giving talks and sharing knowledge as much as I can. So yeah, that's my focus.
Perfect. Thank you so much, Paul, for your willingness to share about Swift and about your work with people. I think we just share the links for people to follow you on social. But if
hmm
you want to add a link for your newsletter or to your blog,
hmm
so the attendees can go follow you, please feel free to do so in the chat. And well, that's a wrap for us. So thank you all so much for joining. We've learned very helpful insights from Paul, and this is the end of this chat. But yeah, as I mentioned before, go and follow Paul in his social media that we already have in the chat as well. And as a reminder, this event is part of our job fair series. We have a full agenda, and our next session that will begin at 4:30 Pacific time are the company pitches and the online job fair. We will have around 15 companies that will talk about the great work they do and that they are hiring right now. So if you're looking for a job, please make sure to go there at 4:30 p.m. Pacific time. And yeah, if you love this chat and just want to learn more about how art can help you land your dream job, please go click on the link that we also put in the chat so you get featured to startups hiring right now. Thank you so much and see you soon in our next chats. Thank you, everyone. Thank you, Paul, and see you later.
Amazing. Thank you so much.
Sure, see you.